What we did in the last unit was we spent a lot of time looking at how to predict the names and formulas of ionic compounds. In this section, we're going to look at how to predict the names and formulas of simple binary molecular compounds that just have two different nonmetals in them. A key thing to remember is that a molecular compound is made up of individual molecules. Each molecule contains a certain number and type of atom present, so the name and formula of a simple molecular compound is going to tell you the number and type of atom present in each individual molecule. So the name nitrogen trihydride, the formula NH4, they both tell me that this molecule contains one nitrogen and three hydrogens in it. So to name a simple binary molecular compound that just has two nonmetals in it, you're going to follow the following rules. Keep the first nonmetal's name the same, but you change the second nonmetal's ending to "ide." Then you go back and add prefixes to indicate the number of each atom present. The prefixes are all listed on the back of your periodic table, so it's not something that you need to have memorized. You just need to know to flip to the back of the periodic table. When adding prefixes, there's kind of two special little rules that you need to make sure to follow. So first thing is, if there's one of the first atom in the formula, you never put mono in front of it. But anytime if the second atom in the formula, if there's only one, you need to make sure to still include the mono in front of it. The other thing is, if the prefix ends in an A or an O and the element's name starts with an A or an O, you drop the A or the O at the end of the prefix. What we're trying to avoid is two A's being next to each other, two O's, an A and an O and an A. So just make sure to follow that other kind of little special rule as well. So let's kind of go through some modeled examples. The first one, NO2, I would keep nitrogen the same. I'm not putting mono in front of it because it's the first thing. Oxygen becomes oxide. There's two of them, so I put di in front of it, so it's nitrogen dioxide. This next example is good because it shows you both of those little special prefix rules being followed. Carbon stays the same. There's only one carbon. It's the first thing in the formula, so I don't put mono in front of it. Oxygen becomes oxide. There's only one oxygen, but it's the second thing in the formula, so I put mono in front of it. I also have to drop the O at the end of mono before I add it to follow that kind of special rule when adding prefixes. Last model problem, phosphorus stays the same, chlorine becomes chloride, and I put a tri in front of it, so I get phosphorus trichloride. I want you to now go through and try the check for understanding problems. So H2O is going to be dihydrogen monoxide, SO3 is sulfur trioxide, and then P4O10 is going to be tetraphosphorus digoxide for the name. All right, next thing is the formulas of binary molecular compounds. It took days of practice to kind of learn the formulas of ionic. Doing the formulas of molecular compounds is super simple. You're simply using the prefix to then identify what the subscript needs to be. The key thing is you do not reduce the subscripts down. Those subscripts are telling you the specific number of each of those nonmetals present in the individual molecule. So dinitrogen tetrahydride, di tells me there's two nitrogens, tetra tells me there's four hydrogens, and I wouldn't reduce that down. I leave that exactly as is. So the formulas, the prefix tells you what the subscript needs to be, and just make sure to not reduce anything down. So go through, we have 3 check for understanding problems. You use the prefix to then identify what the subscript should be. That first one, chlorine monoxide, is ClO. So even though I don't see a prefix in front of chlorine, it's the first thing in the name. Since that mono has to be left off, it's implied that there's only one chlorine. Monoxide, the mono tells me that there's one oxygen. Dinitrogen pentoxide is N2O5, and that last one is going to be P4S9 as the correct formula. So just make sure the prefix tells you the subscript, make sure you're using the correct symbol for each element, and make sure you don't reduce anything down when you're dealing with the formula of a molecular compound.